Number 58. Oh!
Wow, we are still on the journey of logarithm. Welcome to Mathematics Meal. Today on Mathematics Meal, we are going to look at simplification of terms containing single logarithm. That's logarithm part 3. In our previous videos, we looked at the introduction to logarithm. We also looked at the laws of logarithm in the second video. So in this part 3, our interest will be to simplify terms containing what? Single what? Logarithm. Subscribe to our YouTube channel if you have not done that, and then make sure you follow us on Facebook at Mathematics and Science Meal. Thank you. Let's begin this journey. Now, for us to simplify terms containing single logarithm, we have two methods. We have the method we call the ancestors method, and we have the what? Index method. So we'll begin with the ancestors method. But before then, what do we mean by terms containing what? Single logarithm. These are terms containing single logarithm. If you look at this term, just one logarithm, one logarithm, one logarithm. So if I have a term like log 4 in base 2 plus log 8 in base 2, this particular term is no longer containing what? This particular expression does not contain what? Single logarithm, because we have a logarithm here, we have logarithm here. So this one contains multiple logarithms, and the method we use in simplifying this is different from what we use in simplifying terms that contain single logarithms. So when you have a term that contains single logarithm, how do you simplify it? That's the ancestors method or the index method. But in this video, our interest will be on the what? Ancestors method. Let's begin. We are going to look at the steps that are involved in using ancestors method in solving problems concerning terms containing single what? Logarithm. Okay. Now we all know what we mean by ancestor. So we know the ancestor. You talk about ancestors from time to time. Numbers also, they have their own ancestors. So let's look at some ancestors of numbers that give birth to this method. So we look at numbers. Let's start with 2, 4, 8, 16. If I keep multiplying 2, I have 32, 64. I have 1, 2, 8, and so on. The same thing applicable to 3. If we have 3, we have 9, we have 27, we have 81, we have 2, 4, 3, 7, 2, 9, so on. And then we have 5, 25, 1, 2, 5, 6, 2, 5, and so on. That's 3075 also, and so on. So, what do we mean by the ancestor? 2 gave birth to 4, gave birth to 8, so these 2 that gave birth to 4, gave birth to 8, gave birth to 16, gave birth to 32, gave birth to 64, gave birth to what? 128, and so on. So 2 is the ancestor of the whole of these numbers. The same way 3 is the ancestor of the whole of these numbers. So the numbers that are formed from a certain number through multiplication, they are the children of that particular number. So all the numbers that are formed by multiplying 2 continuously are the numbers that 2 becomes their what? Ancestor. All the numbers that we are going to form by multiplying 3 continuously, 3 is their ancestor. All the numbers we are going to form by multiplying 5 continuously, 5 is their what? Ancestors. So at least we now know what we mean by ancestor in this particular concept. Ancestor in this concept. So it's not your ancestor in your culture or in your history. This one is the ancestor in mathematics. Yes, mathematical ancestor. Yeah. So in ancestors method, we have 5 steps that we need to take. So let's take these steps together to solve this problem. So we have log 64 in base 2. Now, why should I use ancestors method? We have already said that one of the methods of simplifying logarithms, terms containing one logarithm, that's a single logarithm, is by ancestors method. So how do I do this? So I have log 64 in base 2. I want to simplify it. Since it is a term containing a single logarithm, I can use the ancestors method. So how do I apply the ancestors method here? We'll go back to our steps, the steps you are going to take to solve the problem. So the first step is take note of the word of the term, the base and the word number. So I've checked the base and the number. Okay, they say identify the ancestor of the number and the base. So what is the ancestor of 64? Actually, the ancestor of 64 should be 2. We just demonstrated that because we can form 64 by multiplying 2 continuously. So 2 is the ancestor of itself. They say identify the ancestor of what? Of 64 and 2. That's the number and the base. So the ancestor of 2 is still 2 and the ancestor of 64 is 2. Okay? Having identified the ancestor, what's the next step? Write the base and the number in the powers of their ancestor. So let's write the number and the base, write it in the powers of the ancestor. So if I want to write 64 in terms of the ancestor 2, 64 is 2 raised to power what? 6. Now 2 in terms of 2 is the ancestor of itself, so it remains what? 2. It remains 2. How did you arrive at this? If you have done properties of numbers, you remember this: 2 divide that, 16, 2 divide this 8, 2 divide this 4, 2 divide this 2, and 2 divide this 1. So 1, 2, 3, 4, 5, 6. So that's this. So 64, if you write it in terms of its ancestor, the ancestor is 2 raised to power what? 6. Okay. So we are done with step number 3. Step number 4. Use appropriate law or laws to remove the powers on the what? On the number and the what? Base. Use appropriate laws or law. Remove, just let's put to remove. So law or laws to remove the powers on the number and the what? And the base. So use appropriate laws to remove the powers on the number and the what? Base. So let's take note of that. So look at the power on the what? Number, and also the power on the base. The power on the base is actually 1, so we don't have anything to remove there because the power here is 1. They say use appropriate law or laws. That means we can use a single law or 2 laws or 3 laws. So in this case, because the power that we need to remove is only on the number, we are just going to use 1 law. And which law are we going to use to remove this power? You remember the third law. We said that m raised to power p in base b is b log what? M in base. So it's p log m in base b. So when the power is on the number, just like we have here, alternatively we can write it as the coefficient of the log. So you see that this is just like this dead law. So we need to transform it in this form. That's what our step is saying. So if we transform it, we are going to have 6 log 2 in base 2. That's what we are. So we just use the third law of logarithm to remove the power on the number. Remember, they say remove power on the number and also on the base, but the base just have power of 1, so removing it will not make any difference anyway. So we have this. So we have removed the power as stated in the fourth step. Now they say notice that the base and the number are what? Are the same. So you notice that the base and the number are the same. I have 2 here, I have 2 here. Then they say simplify to obtain your answer. At this stage, something will cross your mind. What is that? Remember the 4th law of logarithm. The logarithm of a number to its own base is what? 1. So log b in base b is 1. So when the logarithm, when you in a logarithm we have a number being equal to the base, the answer becomes what? 1. So logarithm of a number to its own base we reduce to what? 1. So log 2 to base 2, the number and the base are the same, so this will reduce to 1. So we have 6 times this multiplying this. The whole of this is now 1, and this becomes what? 6. So it means that log 64 in base 2 is equal to 6. All right, we take another example. Let's say we have example 2. It says simplify log 625 in base 5. Log 625 in base 5. Following our ancestors method again. So we are going to have log 625 in base 5. So we identify the ancestor. We have taken note of the base and the what number. So we identify the ancestor of the number and the base. Definitely the ancestor of 625 is 5. We just demonstrated something before we started solving problems. Because if we multiply 5 continuously, we are going to have what? 625. 5 is an ancestor of itself. So the ancestor of 625 is what? Is 5. So write the base and the number in the powers of their ancestor. So what is their common ancestor? 5. So let's write 625 in terms of the ancestor 5. And that would be 5 raised to power 4. 5 is the ancestor of itself, so it remains 5. 625 divided by 5 is 125. Divided by 5, 25. 5 divided is 5. 5 divided is you have 1. 1, 2, 3, 4. So that's why 625 is same thing as 5 raised to power 4. Okay, let's continue to follow. Then they say use appropriate law or laws to remove the powers on the number and the word base. Just like in the previous example, we apply the third law. When the power is on a number, it's the same thing as the coefficient, as the power being the coefficient of the word of the logarithm. So this 4 can now be written as 4 log what? 5 in base what? 5. There's no power to remove here since the power is just 1. So we just use the single law to do that. Okay? Having done that, notice that the base and the number are the same. Now you see that the number and the base are all what? The same. We have noticed that. So what do? We apply the law, this law, that logarithm of a number to its own base is 1. So log b in base b is 1. So log 5 in base 5 will also be 1. So we have 4 times 1, we simplify, and we have 4. So what it means is that log 625 in base what? 5 will give us what? 4. So far so good. I believe we are enjoying the class. So we need to take more examples. You know, I told you when we were describing the laws of logarithm that the moment we begin to take examples, this will become clearer. So let's take the third example. Let's take the third example. You can always pause this video, go through it again until you master all the steps. Okay? Let's see example 3. Example 3, it says simplify log 27 in base 9. So we want to simplify this. Okay? Just one of the examples we gave there. Okay, let's do it together. We have log 27 in base 9. Let's simplify. Okay, we have taken note of the number and the base. Identify the ancestor. The ancestor of 27 and 9 should be 3. 3 gave birth to 9, and it's 3 that also gave birth to what? 27. Okay, beautiful. So let's write. We have identified the ancestor. That's step 2. Step 3, write the base and the number in the powers of their what? Ancestors. So let's write this in the powers of his ancestor. The ancestor is 3. So we are going to write 27 in terms of 3. That's 3 raised to power 3. And 9 also in terms of 3. And that's 3 raised to power 2. So the ancestor of 9 is 3. And the ancestor of 27 is 3. And we have written them in the powers of their ancestor. 9 is 3, 3, 3, 1. 1, 2, 3 raised to power 2. 27 is 9 here, 3 here, 1. 1, 2, 3. That's why it's 3 raised to power 3. Okay? Now, using appropriate law or laws, remove the powers on the number and the what? And the base. That's beautiful. So we are going to use laws now because we have power on the what? On the number and also on the base. This is power of 2. So we have powers here and here. Power on the number, power on the what? On the base. So we'll be we're going to invite another law apart from the third law. That's likely going to be the 6th law. You remember that law, the 6th law? I think it should be the 6th law, where we have that log m b raised to power n, same thing as 1 over n log m n. Sorry, b. We have this law. So we are going to use 2 laws to remove the powers. The other one is saying m raised to power p. B is p log what? M in base b. Now, we are going to use this law to remove the power on the number, and then we use this law to remove the power on the base. So let's do that. Let's remove the power on the base. The power of the base, when we take it, we are going to have 1 over 2. That is, as we have log m b raised to power n is 1 over n log what? M base b. We have this. When the power is on the base, that's how we remove it. We have this. Now, when it is on the number, we have that. We have p log what? M base b. So this. So here I've removed this one using this law. I also need to remove this. So 3 moving. We now have 3 log what? 3 in base what? In base 3. Right? So how did we arrive at this half? Applying this law, because the power is on the what? Base. So we applied it, we arrive at this. How did we arrive at this 3? This power that is on the number, we apply this law, and then that's how this 3 appeared here. So notice that this and this are the same by our step. Notice that the base and the number are the same. So simplify to obtain your answer. So let's simplify. We are going to have 1 over 2 times 3 times log 3 in base 3 according to our 4th law. Log b in base b is 1. So logarithm of a number to its own base is 1. And the number and the base are the same here. So the log 3 in base 3 will give us what? 1. You see how we are laying emphasis on this so that it will all become very simple and very clear. So if we multiply this, we have 3 over 2. So it's 3 over 2 or 1 whole number 1 over 2. So log 27 in base 9 will give us 3 over 2. Wow, that's beautiful. Very, very beautiful. So I think we need to take one more question, and then at the end of this question, we'll now give you a takeaway question. So let's look at example 4. Let's try a situation where we'll have what? A decimal. So we'll say simplify. Simplify log 0.001 in base 100. In base 100, okay? Let's say in base 100. Right, let's do that. We have negative sign already. We have a negative sign at the end of the day in this question. Don't ask me how I know. Of course, I should know. So in this case, we have a decimal. So let's go together. So if I have log 0.001 in base 100. Now, we say something here. Change decimal fractions to ordinary fraction and mix numbers to improper word fraction where necessary. So we have decimal, right? So we need to change it to what? Ordinary fractions. So that's the first thing we do. We have log this 1000 base 100. So it means that 0.001 is actually 1 over 1000. That's what it is. That's what it is. You remember how we changed decimals to a fraction. 0.001 is still 1000, so that becomes 1 over 1000. You still remember that, I know. So 0.001 is 1 over 1000. We have a challenge here because of this fraction, but let's see if we can get the ancestors. The ancestor of 1000 is 10, and the ancestor of 100 is also 10. So let's go to their ancestor. So log, they say identify the ancestor, and the ancestor is 10. Write the base and the number in the powers of their ancestor. So if I write this, it's going to be 1 over 10 raised to power what? 3. And 100 is 10 raised to power 2. So this one is 1 divided by 100 raised to power 3. That is 1 over 1000. So I can put it in a bracket. So log, I have 1 over 10 raised to power 3 and 10 raised to power 2. That's what I will have there. Because 10 is the ancestor of 1000, also ancestor of 100. So writing it in the powers of the ancestor, we have this. We know that 10 raised to power 3 is 1000. That's 10 times 10 times 10. And 10 raised to power 2 is 100. 10 times 10. Okay. Okay, I think it's time for us to clear this. We can clear this now. We have mastered our rules, so we can clear this to some extent. So use appropriate laws to remove the power. But I have a case here because this is 1 over 10 and this one is 10 raised to power 2. So this is in fractional form. I can apply the law of indices here. So this expression becomes log 10 raised to power minus 3, 10 raised to power 2. Why? In indices, a raised to power minus m is 1 over a raised to power m. You can watch our video on indices to understand this. So if I have 1 over 2 raised to power 4, I can bring this up and it becomes 2 raised to power minus 4. So this is this. So since I have this, I just decided to write it in this form, and that's why we have this negative sign. Okay, so having done that, we can now apply our laws. Use appropriate laws to remove the power. Let's remove the power here. We have done similar thing here. So this becomes 1 over 2. Remove the power here. We are going to have minus 3, then log 10 in base 10. You remember the laws that we use. We use the fifth law to remove the power on the what? On the base. And then we use the third law to remove the power on the what? Number. That's what we did. Now the fourth law will come into place. Logarithm of a number to its own base is 1. So 1 over 2 times minus 3 times 1. That will give me 1 times this is minus 3 over 2, or minus 1 over 1 over 2. Wow. So far, so good. I believe that with these 4 examples, you can now see how we can apply ancestors method in simplifying terms containing single logarithm. I will not leave you empty-handed. Just take down this takeaway question, solve it, and make sure that you submit it. Very important. Solve these questions and submit it. So take away questions. Simplify the following. Simplify the following. We have log 32 base 8 to log 0.125 base 16 and 3 log. These are the takeaway questions. Make sure you solve these 3 simple questions using the principle of what? Ancestors method, or the steps involving ancestors method. Watch the examples we have solved in this video and use the knowledge of those examples to solve these problems. Make sure you solve and submit the answers to this question. Thank you for watching our videos till now. In our next class on logarithm, we'll be looking at the second and use in simplifying terms containing single logarithm, and that method is index method. You cannot afford to miss that particular class. That's why you need to subscribe to our YouTube channel, so that once that video is uploaded, you will know about it. Thank you for watching our videos. Remember, you need to keep sharing the videos, watch our videos, like our videos, and always leave a comment for us. Till I come your way next time, keep enjoying mathematics meal and keep being healthy in mathematics and in sciences. Remember, I'm still your friend and your brother, and also your tutor, Engineer Ike Okechukwu. I love you.